this computer. Okay. Now I'll start sharing my screen again. Okay, share. All right, so here we are. We've got our Unity stuff up and happening. It's just a happy thing. All right, now, the reason I called this project cat is that I have a sound file out here. Which is my old cat. You heard that, right? Okay, sound is working? Okay, good. So we're going to set that up so that we're going to just trigger that cat from a key. Again, I was just going to play it. So first of all, let's create an empty object. Okay, game object, create empty. And we'll call this object cat sound. Okay. And let's now add a component to it. Okay, we're going to add a new script. Okay, we're going to call it meow. There we go. Okay, and of course, before I forget it, I will add the component, the audio source, because I always forget to do that. So basically, this is pretty much ready to make some sound now. Now we have to add the RTcmix stuff. And here's the thing. Notice that I have a new Unity package, and I started numbering them now, 0.91. That does a couple things. First of all, it fixes the problem that we had early on where it was playing on Unity and it would go like that. It was kind of a buffer issue. The second thing it does is that I discovered a small bug only on OS X where it was certain standalones that you tried to build, it would not work. So that's been fixed. Now, I also tried to see if I could just make it built in so that you wouldn't have to click that unsave code. And there is a way to do it, but it turns out that way is actually more tricky than actually just clicking the unsave code thing. Okay? There's a file that you could have included, but it's not clear that that's a good thing to do. So what we're going to do is bring this in. Okay? We're going to import everything, and then we'll go up here to our project settings. We've got the player selected. Click the unsave code. This seems to be the way that Unity really wants you to do it for this stuff, okay? So let's go ahead and set this up. We're going to get our RTcmix prefab going. Put our main up here. All right. And let's go back. And now let's edit some code real quick so that it'll play back our cat meowing. Oh, let's bring the cat in as an asset too, okay? We have to take our, where to go? Down here, week 11. Nissa.wave, the name of the cat was Nissa, all right? So we've now got that in there. It's happy. It meows. You know, life is good. We can play it down there. Yes, there it is. Okay, so let's open up our meow script. Okay. Go, go, go. Go, Visual Studio, go. Yes. There it comes. All right, I need to do these updates. Now, I'm not going to bring the beep object up. I'm just going to take a look at the beep script. And again, I just use that as kind of a template for bringing the stuff in that we need. So here we go. I'm going to copy all this nonsense here between those two curly braces. Copy it. Now get rid of beep. Go to our meow script, paste it in, and we're pretty much ready to go, except this is just going to make a single sound, okay? So let's save it. Now, let's go ahead and start modifying it to do what we want it to do. First of all, we want to figure out the path to that sound file. String sf path equals application dot data path. That will get us to that assets directory, all right? So then we want to set up the string for our RT input to bring this file in. And we'll call this RT input string. Okay, and we're going to say here RT input. And then we're going to escape a quotation. And then we're going to add the SF path to that. we're going to escape, and we're going to put in, we don't escape it, no. We're going to put in /nissa.wave, okay? And now we're going to escape a quotation, and that's it, all right? What have I done here? Okay, RT input. Okay, let me just look at my thing here. RT input / oh, this needs to be another. All right. Okay, basically we're creating little fragments of text, okay? Everything within double parentheses here, that's a little fragment. And the first fragment is RT input, open parens, and then a quotation mark, because that's the way the RT input command looks in RTcmix. Then we add in SF path, which is already a full string, and then we add between these two quotation marks /nissa.wave, and then we escape that second sort of thing. Basically, we're constructing this RT input command to take us to this assets directory where the Nissa sound file is. Okay? So let's go back. And now that we've constructed it, we can say RT input, we can say, RTcmix.send score, and we're going to send the RT input score, input string. We're going to send it to objno, and there we go. That will then open up our sound file and get it to happen, okay? Now, this was where I was going to set it up so that we could actually play Nissa just like 5 seconds after. I was going to set up a bang that was going to like bang after 5 seconds. But just for fun, let's set it up so that we will actually play the sound file whenever we hit the M key for meow, okay? And I need to look at something real quick to refresh my memory, okay? Because I never remember stuff, okay? Gosh darn it. Okay, all right. Let me go into Unity stuff, okay? And I'm going to look at my observer move script here, okay? Yeah. Okay. Just copy one of these things out here, okay? And I'm going to explain what this does here in a second, okay? All right. Let's go down here and in our update method, okay? Let's get rid of these Control M things. Okay, and we're going to get rid of this. We're going to get rid of this. Let's get rid of those and put in new ones. Okay. And let's look at the documentation. I'm going to select key code, okay, and I'm going to hit, let's look at get key first of all, okay. If I hit command single quote, it'll bring up the documentation for this, okay. Input.getKey returns true while the user holds down the key identified by name. All right, this is interesting. Ah, there we go. Right. Here's what we want to do, okay? Input.getKey. All right. Now we're going to test this out first, okay, before we do stuff with Nissa. So let's do a debug.log, okay? We'll say, hey, what's happening here? Well, first of all, I'm working in the update method because this is where this kind of stuff happens. Okay, this on audio filter read, that's where audio stuff happens. This is interface stuff and graphics stuff that happens in Unity. This gets called once every frame. Okay, so generally it's going to be about 50 or 60 times a second, maybe less than that, depending on how fast your computer is. Okay, and what this does is input.getKey looks and sees if you're typing a key, and if you are, that returns true. So if that becomes true, then it will execute this stuff. If it's not true, your update method just continues to go. Okay, so let's give it a try and see if this is working. Okay, I'll leave the wavetable in there so we can hear if we're hearing any sound to make sure that that's all working too. But let's go back now to Unity, and it'll compile that. And the output that we see is going to be in the console. Okay, so let's get rid of this nonsense here. And let's play it. Okay, and you should hear tone at the beginning. There's the tone. Now watch what happens when I press the M key. Hey. Okay. However, there is a small problem. Every time I hit the M key, notice that it put a whole slew of stuff out there. That's because if you remember the documentation, what did it say? It said, let's go back to it.
Is it that it's whenever the key is down?
Yes, whenever the key is down. And basically, remember it's sampling this 60 times a second, so that it actually got a whole bunch of stuff, like right away, okay? So there's a way around that, okay? And the thing that we want to do is, let's go back to our code here. Let's look at getKey. Okay, input. Look just below it. I just read too quickly. There's input.getKeyDown. Okay. Returns true during the frame. That's the single frame. The user starts pressing the down key identified by name. GetKey returns true while it holds the key down. Now, Yuval, this might be important for you because you could actually hold the key down and it would raise the pitch continuously. But in this case, we want to trigger one instance of the cat meowing. We don't want to trigger like 20 of them. So we're going to use, instead of input.getKey, we're going to use input.getKeyDown. So here we go back to Visual Studio, getKey down. All right. And now, let's go ahead, since I'm pretty convinced that this is going to work now, let's go ahead and put in, let's get rid of our tone here, because we don't want a tone in this, okay? And what we're going to do is, instead of this, we're going to say RTcmix.send score, and the score is going to be stereo, in skip, out skip, duration is about 9 seconds long, okay? Amplitude, how much in the left, how much in the right, no. Okay. Since we've already done an RT input, that cat file is open. So now this command, this is an RTcmix command that will play back an open file. And the parameters, I just have this memorized, is how far do you skip on the output before you play it? How far do you skip on the input before you play it? We want to play the whole thing, so we're going to start at 0. How long is it? What's the amplitude? And this is a number between 0 and 1. This is like the input channel 0 comes in. How much are you going to put in the left? How much are you going to put in the right? This is input channel 2. How much are you going to put in the left? How much are you going to put in the right? So 0 and 1 will just segregate it up so that the left channel will go to the left, the right channel will go to the right. I could turn it into a mono file by saying 0.5, 0.5, because then it would take both channels, put them both in the center, okay? If that's confusing to you, write to me and I'll explain it better later, okay? But right now...
Do you need a close paren after?
Oh, yes, I do. Thank you. In fact, I did that when I was working up the test version of this, and I was going, why isn't it working? Why isn't it working? All right, so here we go. With any luck, we will now be able to play the cat by hitting the M key, okay? Well, I should have actually have kept the whatchamacallit in there. Click on play. Oh, we'll just leave that. Okay, because now you can't tell when. I'll tell you when I'm hitting the key. Okay, here we go. Starting it up. Now I hit the M. I hit the M again. I hit it again. I hit it a whole bunch of times. Okay. So there we go.
A herd
All
of
right.
cats.
A herd of cats. This is just the cat sort of, whatever. Okay. Now that's cool, and actually that works better than I had feared. Okay. However, we're going to do something like not good. Suppose that you're just like me and your typing is really bad, and suppose that I introduced a space up there. Now what this does is this destroys the command that will find the cat, because instead of the path then slash nissa.wave, it'll be the path with a space and then slash nissa.wave. And your computer is going to go, I don't know where that is. What's wrong with you? Okay. So let's now see what happens when I try to play this. Okay. Here we go. It's building it. So I turn it on, right? Okay. And I hit my M, nothing happens. I hit it a whole bunch of times, nothing happens. But look, I'm not getting any errors in my Unity console or anything like that. What's wrong? Well, I can check this stuff, see if there's errors. No, there's no errors. That's because the error is in the RTcmix side of things and not the Unity side of things. How do I see those RTcmix errors? Well, the first thing you want to do is turn on the RTcmix printing capability, okay? And you do that by saying print on, and it's an RTcmix function for the object number. Shoot. Too fumbly fingered here. Obj no. So this is an RTcmix command, just like RT input, just like stereo, all that good stuff. Only what it's doing is it's turning printing on. Now, why do we have it off by default? Because this is actually a somewhat expensive operation in terms of computer CPU. And that becomes an issue when you start building a large Unity project, because you're going to push the limits of what your computers can do. So you have to explicitly turn it on in the Unity version. Now, it's turned on by default in the other versions, the standalone versions of RTcmix. All right. So we turn on the print, but if we run it now, I'll tell you right now, we won't take the time to run it. It's not going to work because we have to put in this command that will enable us to see the printing. And again, that's another efficiency thing. Now, this command has to go in the functions where RTcmix is doing stuff. Okay? So now, when I view this, when we run this, you're going to see the printed output of what happens when these get sent. So after the send scores in a particular function, like in the update function, I have to have a print object. Here I have to have it because this is just when RTcmix is running, okay? And up here I have to have it when it's initializing and all that, all right? So let's now go back to this. We've got our console up, all right? And let me try running it. Okay, and let me try hitting the M. Oh, I forgot one thing. Okay. Actually, that should have worked. All right.
Is it an ordering thing? Does the print RTcmix
It has to come at the
be...
end. Yeah, it has to come after the directives have been sent. Okay, let me try this again. Like I said, I have a backup plan, and I can show you in this other thing. Huh. Well, gang, that was supposed to work, and it sure didn't. Yeah,
I think it's printing, but you're looking at the wrong error
Oh, you're
message
right.
thing.
Oh my gosh, yes. Ah, look at that. Okay. All right. Yeah. I think you're. Yeah, I forgot the new versions of Unity. It doesn't print stuff by default. Okay. It shows you here directives, warnings, and then these would be actual errors in Unity. These are errors in RTcmix, so they're going to come out as directives. And there they all are, as a matter of fact. I'm going to get this cleared. Clear on play. There we go. All right, now it's all cleared. Yes, Jesse was right. Thank you, Jesse. Okay, so now let's go ahead and run it. All right, and if I turn this on, I think you should see it happen in real time. Okay, yes, there it was. Okay, so right off the bat, you can see, oh, it's doing stuff. Oh, look, there's an error. It says RT input, blah, 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 and there's that space right there. No such file or directory. So that's how I figured out that, well, I've got something wrong here. And if I type M up here, you'll notice that every time it tries to run the stereo stuff, it says, ooh, no input source open. That means because it couldn't find the sound file, so it's not doing anything. So this is the mechanism you can use to kind of debug your RTcmix scripts, because it pretty much tell you right what's going on right there. No such file or directory. Oh, there's something wrong there then. And then I can go back and say, oh, it's because I typed a space there. Fix that, it's going to run, and at this point it will print all this stuff. Let me just go ahead and do it. Yeah, what the heck. Okay, so here we go. Stop this. Let's try clearing this, and let's run it. And now you'll see when Unity first starts, it will happily say, oh, look, it found this thing. It tells you the type. It tells you the sampling rate, the number of channels, and the duration, and all kinds of good stuff. And now when I hit my M, it meows. Yay, look. And see, it tells you all this good stuff that it does. All right. So that's how you print things to get the error messages in RTcmix, okay? I'll leave those in there because I'm going to put this project up for you all to see, okay? However, actually, yeah, I'll leave it in. What I want to do now is build a standalone with this, okay? So our standalone is going to be filled with this nonsense because I'm not going to keep the standalone forever. But I want to show you how easy it is to build a standalone, okay? All you have to do is go up to File, okay? And you want to go to Build Settings, all right? Don't do Build and Run. That's just kind of annoying. I mean, it's... Now, this brings up this, and you have to modify this. You have to tell it which scenes to build, okay? Oops. You know what? I forgot to save my scene here. I'm going to save it. All right. Let's go back up here to File, Build Settings. And you can actually list the scenes by hand, or I can just simply add the open scene, which is the only scene I have here. And then you can do all kinds of like target platformy stuff here. That's pretty much all set by default and it's okay. And now all you have to do is hit Build. And then it'll put it somewhere. Let's put it right up in the top level here. And we'll call this Cats Galore. Okay. And we'll save it. And now we're going to wait a little bit while it actually builds this application. There it goes. It's building it. It's building it. Oh, look at that. It's building it. Oh, it's doing all kinds of stuff. It's compiling shader variants, which is pretty amazing because I don't even have any things in the scene. Here we go. Almost done. It's so close, guys. Now, I have to tell you, like substantial projects, they do take a while to build. Well, basically, we're done. And look, we have an application called catsgalore.app. Oh, we're so happy. We're going to run this app. Okay, so I'm going to double click on it. Oh, there it is. It's made with Unity. There's our thing. Now I hit M, and nothing happens. Okay? Why didn't anything happen? Well, it's because there's one thing that Unity doesn't do when it's building an application, okay? This particular file, the sound file type, does not get copied by default into the Unity bundle. Now, if you're on a Windows machine, there's actually a data directory where you would put this stuff, but the assets directory, when you build a standalone, here's what we're going to do. We're going to open up the bundle for that standalone, okay? And you do that by control-clicking on this, and it says Show Package Contents. This top level of contents is where your assets point to. What I'm going to do is I'm going to take this cat sound file, and I can just take it from my Unity project, and I'm going to drag it over here into the contents by hand. Okay? Once it's there, that SF path nonsense that we did, that application.data path, it will find it now in that application. So now, if I go back to my catsgalore.app and I run it, now, there we go. Yay. Okay. Now you hear how it was breaking up a little bit? That's because I left those print statements in there. Okay. Because they do a lot of stuff that's not good in terms of efficiency. Okay. So yeah, that's how you build a standalone app. Now we've got this Cats Galore thing, and we can send it to our friends and go, hey, isn't this great? And you can discover the joy that is Apple with their stupid gatekeeper stuff, where you have to do that nonsense where you, yeah, strip out the developer stuff. Okay? All right. So that was the first big thing I wanted to show you. Now, Yuval, this is going to be important for you because I want to show you how to do, how much more have I got to do here? Oh no, this is going to be so simple, okay? Now, let's suppose that we're going to start a new Unity project here. So I'll save this guy. Okay? And we'll go to, so we don't need this anymore. So let me get rid of that. All right. We don't need this, so I'm going to quit Visual Studio. All right, let's go up to our Unity Hub. Let's create a new project, okay? And we'll call this multi-beep, okay? Hey, is my typing too annoying? The loudness? It's not bad? Okay, good, good. Next time I will sort of like use my mic. All right, so we got multi-beep happening here. What I'm going to do is we're going to set it up to do a repeating beep, okay? So that's going to be pretty trivial. But then we're going to add within that same sort of function, we're going to add a second repeating beep that will be beeping at a slightly different rate, okay? And I want to show you how to do that because there's a trick to it, and it's you'll see what the problem is, you know, when we get into it. This won't take too long to do, okay? All right. Okay, come on, Unity, go, go, go. There we go. Yes, it's opening the project. Yay. There we go. Yay. All right. Now, the reason that I have to resize this is because it's hidden from me by your happy faces. So, and then I can't also get up to this. But anyhow, that's okay. All right. So let's go ahead and get it set up. Let's create, again, I'm going to create an empty object because I don't need anything actually graphically going on here. And we'll call this multi-beep, okay? Now, let's add our components to it. First of all, we're going to make it audio source. Again, it doesn't matter where that audio source goes in. It can be ahead of this script for whatever reason, okay? We'll call this we'll call this beeping. You can call it the same name as the object, but sometimes it gets a little bit confusing after a while. So I'm going to create this script, create and add it. There we go. Let's now bring in our new RTcmix stuff. Okay, which one is which? There we go. 0.91 is 1. Oh, by the way, I don't have that up on the website yet, okay? So wait, I'll get it up probably by tomorrow, Friday. And I'll also make a link from the class web pages. So that's the one to use, especially if you're going to be using standalones or you want to play it on Zoom, okay? All right, so we got to go up now and do our project settings, set to the player, unsafe code. Yay. All right. So now let's go in and bring up our prefab, oops, not the README, the prefab of RTcmix main. Put it right up there. Okay. And let's now open up our beep, multi-beep thing, and we'll add the script to make the beeps, okay? Okay. Here we go, assets. Now edit beeping. Yes, I'm enjoying Visual Studio, but not now. Okay. So again, I'll do the same stuff. We don't want the README. Let's go into our scripts. Let's look at the beep script real quick. Grab what we need from it. Command copy. Get rid of this. Go to beeping. Paste it in. All right. And now, let's, instead of a single beep here, let's make this be a beep that's going to be 0.14 seconds long. And let's have it beep. Now we're going to add one more thing. We're going to add a max bang of 0.2. Okay? And let's now let's copy this all out. We'll go down here and we're going to say if RTcmix dot check bang RTcmix for our obj is equal to 1, then here's what we're going to do. That. What are we doing? Well, we're creating a wavetable that's only 0.14 seconds long. All right? And everything else is the same. And then we generate a bang at 0.2 of a second after that. So every 0.2 of a second, when it sees a bang down here, it will resend that whole thing. We're going to generate another beep that's 0.14 seconds long. So we're going to get a beep basically 5 times a second, every 0.2 of a second. So let's go back out and listen to this, okay? And it's going to compile. Look at our multi-beep if we want, and we'll play this. There we go. Cool. It's beeping, all right? So now we want to add another beep, okay? And let's go up here, and we'll just copy this whole score. Okay, and let's make this be at, say, how crunchy, let's make it be like a tritone above middle C. So that's going to be a minor second there, okay? And let's make this one be also 0.14 seconds long, but let's do it every 0.31 seconds. So this will be a slower rate, okay? And we schedule a max bang for that. Here's the problem. We have 2 max bangs going on, right? Down here we can check if there's a bang, but we don't know which one it is, okay? Is it the 0.21 or is it the 0.311? And this will just wind up creating just like beeps all over the place because they're all going to generate those bangs and they're all going to be interpreted those bangs and they'll all do the same thing. How can we disambiguate the things that are happening? Well, RTcmix has another capability called MAXMESSAGE. And the first argument is the time. So that's going to be every 0.2 of a second, or it's going to happen in 0.2 of a second. And we can give it a message. Let's say 1. We can say message here. And we can say 2. So down here, Instead of checking for a bang, we're going to check for a message, and we're going to see if the message is 1 or if the message is 2. If it's 1, we'll send off that guy. If it's 2, we'll send off that guy. Okay? How do we do that checking? All right, well, this is a little trickier than just checking the max bang, because this max message, you can actually give it a whole bunch of values after the fact. So this will actually give you an array of values, okay? Now we're going to use one element of this array for this particular simple project, okay? We're going to use the first one. But we need to come up with a way of intercepting that array, and we do it like this. We say float n vowels, excuse me, okay? So we've declared an array. It's going to be filled with floating point numbers. We don't know how big it is, all right? And we're going to check it by saying int n vowels equals RTcmix dot check vowels RTcmix, all right? Now, we don't just give it obj-no. We have to give it some other stuff here, okay? And we're going to say out vowels obj-no. And then if n vowels is greater than 0, we're going to do stuff. What's going on here? All right, we've declared an array calling it vowels. Now, notice that in this check vowels RTcmix, we're using that array there, but we're tagging it with the wonderful C# keyword out. That means that this array is going to be filled inside that function, okay? And obj-no is we're just checking this object number. And it returns how many values it put into that array. Now, if the timing hasn't been reached, if it's not 0.2 seconds or 0.31 seconds, it's going to return 0 because I said, sorry, it's not time yet. Once it hits that 0.2 or that 0.31, then it will return how many values it put in. Now in this case, it's going to be just 1, all right? But here's where we can check it. And we can say if vowels sub 0, which is our first element, if it equals 1, we're going to do something. Well, what is the thing we're going to do? We're going to send the first message. Okay. Or if vowels sub 0 equals 2, we're going to send the second message. All right. And that's because we put a 1 there.
Equals 2.
And we put a 2 there. Yes, thank you, Rainey. Just checking you guys, okay? All right. So this is the way that we can disambiguate or get information coming from RTcmix back into Unity, all right? So essentially, this is now set up because this will send out our first 0.14 second long note, and it'll generate a message 0.2 of a second, and that message will be 1. This one will do that, and the message will be 2. Down here, when it reaches 0.2, it'll say, I got something, and you'll check, and if it's 1, you'll resend it again 0.2 of a second from then with a message of 1. Or if it's like 0.31 seconds, then you do that. So now, this should just be a happy RTcmix. And we'll get this going, fire it up, and we should hear 2 tones. Yep. So there we've got our cool polyrhythms, and you know, life is happy. Whoa, this class is going good. Everything's kind of working like it should. Thanks to Rainey, for example. All right. So that's that. All right. We only have 2 more things to show that I wanted to show, and they're actually quite simple, and they don't really deal with RTcmix per se. All right. The first thing is timing. Let me start up another Unity project. Like I said, I'll put these on the web page so you can download them and use them as a basis if you want. Okay. This one we're not even going to bring in an RTcmix package. Okay. Let's start a new project. Okay. And we'll call it timing. You know, I meant to call these like week 11 dash timing. I'll go back and change the names later because that's a little bit generic and it'll be hard to find in the future when you've got like a bunch of projects. All right. Okay. What am I doing? Well, we have been dealing with time in RTcmix, you know, with scheduling the messages, with max bang, with all that good stuff like that and everything, you know. However, Unity also has a timing mechanism, all right? And it's useful in the update method if you're timing graphic events, like if you want a certain object to start spinning, like 7.3 seconds from when you start the game, or when you shoot it, or whatever you want to do to it, okay? And I want to show you what that Unity timing mechanism is, okay? Because it's not really intuitive. No, it kind of makes sense, but it's a weird sort of sense, okay? Let's just create a new object here, okay? And we're just going to call it timing, okay? And on this timing, we're going to add a script. We're going to call the script timing. We're just going to be very boring about this and call everything timing, okay? All right, so let's edit that script. We're not going to do any RTC mixing or anything like that, okay? Here we go. All right. Unity has a class, okay? And I'm just going to put it here called time, okay? And if I select it and hit Command single quote, it'll bring up the documentation for it. And you can see that there's a lot of stuff, okay? All these things are aspects of the Unity time object. So for example, frame count. If I say time.frame count, it'll give you the total numbers of frames that have passed, okay? So this is all information you can use to do timing. Now I'm going to do something very simple, okay? I'm going to say that at 7 seconds after starting the game, or starting the virtual reality thing, I want something to happen, all right? So to do that, I'm going to create a float variable called myTime. And I'm putting it up here because I want that to be accessed by all the functions in this timing class, okay? Like when I do it down here, it would only be accessible in that start time thing, all right? And when it starts, I'm going to say myTime is going to be equal to 0.0 f. All right. Now, how do we change that and determine when 7 seconds has gone by? Well, we say we're going to add something to it. Time, yeah. Here it goes. Forgot to do this. All right. What is this? What is time.delta time? And why are we adding it over and over to myTime in the update method? Well, because if myTime becomes greater than 7.0 f, that's when we do our stuff, okay? Right now, what we're going to do is we're just going to do a debug.log, and we're going to go, hey, I would do something, okay? what's going on here? Well, time.delta time, if you read the documentation, it's how much time has passed since the last display frame. So basically, if I add up all that time, that's keeping track of basically where we are in terms of time. So if I continuously add that to my time and check to see if my time starts at 0, after I added up enough frames that it's now reached 7 seconds in, that's when I do this, okay? And I'm going to say my time is going to be equal to 0.0. I'll reset it. So this will happen every 7 seconds, all right? Now, I could just shut it down there if I wanted to, but in this case, I don't want to. Well, why do I have to do this? I mean, why can't I just have something that's just kind of constantly measuring time? It's because the frame rate in Unity is variable. The frame rate is determined by how fast your computer can run. Like, remember when I tried to run the HDRP
High
stuff?
definition under
Yeah,
pipeline.
yeah,
Yeah.
right. And I think the frame rate was something like 1 every 2 or 3 seconds. I mean, it was still actually running, but it was going kind of like that. Generally, you don't want to get a frame rate below 24. There's actually a Unity thing, if you get really into it, there's one of those little gizmos where you can see the stats about your VR simulation, and you can see what the frame rate is. If you get below 24 is even pushing it a little bit. I think the standard frame rate in movies is 29 frames a second, something like that. Yeah. And Unity tries to run a bit faster than that. Usually, like I said, I'm usually running up about 50 or 60 on my Windows machine, which is built for gaming. But this will actually allow you then to take into account the fact that the time is variable, because this is giving you how much time has elapsed since the last frame. So that's going to change. And in fact, it's going to change depending on what you're rendering in a frame. This is not a constant value. It's funny, if you watch it, you can see that it's like kind of jittering all over the place, okay? Well, let's just go ahead and run it. And again, I'm going to bring up my console here, and you'll see, all right, here I just hit start. Here it goes. Okay, 1001, 1002, 1003, 1004, 1005, 1006, 1007. Yay! 1001, 1002, 1003, 1004, 5, 1006, 1007. Yay! Okay. So basically, that's how you use the Unity timing stuff. Okay. And again, for art, you can actually use RTcmix to do timing for Unity events, but it's a little tricky because if you have that on filter read thing happening, like I said, that's devoted to audio, and you can't actually do graphics rendering inside that function. You have to set a flag, and you have to do the graphics rendering inside the update function. So update would have to say, oh, have you given me a flag inside the audio stuff? And if you have, then you do your rendering. But this is really how you should do it, because that's the way Unity wants you to do it, and it works very well. Okay. All right. Okay. One more fun thing. Let me quit Visual Studio. And it's interesting. I don't know if any of you will ever. Oh, let's save it. Will ever use this, but it's kind of nice to know. I wanted to show you how you can import real-time audio into Unity. So suppose you were creating not a VR scene but an AR scene, you could actually process the sound of the world around you inside your Unity simulation. Now this can lead to all kinds of fun. This is something that I want to do at some point. I want to actually set up VR goggles, and Apple is coming out with some pretty soon. There's some that you can buy off the shelf that will actually also display what you're seeing, so that you can essentially overlay the world with bizarre Unity stuff. Or you can take the real-time sound of the world and make it all go like this if you want to, you know, and come up with all kinds of fun things to do. Turns out it's trivially simple, okay? I looked into this for Larry Lewison, and I thought, oh my God, it's going to be really, really tricky. But it's not tricky at all, okay? Let's go ahead and start a Unity project. Where's my Unity thing? There it is. Okay, and we'll call this real real-time audio. Okay, here we go. And I'm going to bring up my cheat sheety thing because I want to copy and paste this stuff, because otherwise it's going to, well, I suppose, like, no, I don't want to type it in. It's getting late. Okay, let's get Unity going. Come on, Unity. Oh, wow, I didn't notice it had a little timery thing on there. Wow, how cool. But it's taking its time. There we go. Where is Unity? I must have been doing, oh, there it comes, there it comes. Okay. Ah, okay, good. All right. And we are going to use some RTcmix because we're going to process the audio a little bit, okay? So let's again create just an empty object, okay? And we're going to call this mic in, or we'll call it mic, okay? And let's add the stuff we need to add to it so that it can make sound. Oops, I gotta bring this away from your happy faces over there. Okay, let's add a component. Let's add a script. Okay, we'll call this mic sound, okay? And let's add our audio source business. Okay, get rid of that. Audio source. So we're ready to roll. Let's bring in our RTcmix stuff. We want the 0.91 package. Bring that in there. Import everything. Okay, go here. Go to my prefabs. Bring up RTcmix main. Put it there. Okay. Go back to our assets. Let's now do our unsafe code thing. Player. Scroll way down. Unsafe code. You can tell I've been doing this unsafe code a lot now, so I know exactly where to scroll. All right, so that's good. All right, now let's edit mic sound. Okay. All right. Here comes Visual Studio, and I'm going to bring up the stuff that I did ahead of time, and we're going to do a little copy and pasting here. Okay. First of all, let's go ahead and get mic sound set as a RTcmix playing object. Here it comes. Let's go to this. We'll go to our scripts. Let's look at the beat script. Copy out all the stuff we want. Copy. Paste. So now it's making a beep, but we're not going to have it make a beep very long, okay? Because we're going to go and grab what we need from here. Okay. Right. This is what we need. All right. And let's go ahead and send our score. And, you know, rather than me, well, yeah, I could probably. Okay, we're going to do two things. First of all, we're going to say RT input audio. I have to escape those things, all right? Because it's going to be receiving real-time audio into RTcmix. Okay, and what we're going to do with that real-time audio, we're going to say RTcmix.send score. Oh, shoot. I want to say pan echo. Okay, and pan echo takes an in skip and out skip, a duration, it'll just go forever, an amplitude, a left channel delay, and a right channel delay, a feedback amount, ring down duration, which we don't really need, but we're going to put it there anyhow. Okay, so we're going to take what we come into our microphone, and we're going to add a 2/10 of a second delay to the left channel, and a 0.35 second delay to the right channel, and it ping pongs back and forth because each time it gets decreased by 0.7. So we're going to get echoes over and over again. All right, we have to do one more thing. We have to change this to a 1. I'll put this in here because 1 to show to set up input processing of sound. Again, that was an efficiency thing. You know, I think I'm going to change that to just be that by default, though. Okay. All right. What's happening here? Well, all this gunk that I just copied and pasted, this is what I found on Stack Overflow. All right. Turns out, again, there's a built-in Unity audio system, and a lot of it uses these things like audio source. You can look up the documentation for it. All right. That actually references this audio source that we added to this object, right? And notice that it has an audio clip and an output and things like that. You're going to see that change as a result of what we're doing here, because we're setting the clip to be start the microphone. And null means you're just going to use the default mic of the system. All right, you can actually specify which input you want by putting it there in quotation marks, okay? I forgot what this is, but this actually is critical. It's basically how long do you cycle this internal buffer, all right? And if you make it too short, you get like really weird click objects. If you make it too long, you get huge latency. I fooled around, and this is about right. I think it's a 1 second, but that's not really what the latency is. And that's obviously the sampling rate, okay? And we set it so that it's going to do this over and over again. And this is basically the thing that tells you when you recycle that buffer. And then you turn it on with that. Now, if what I said makes no sense, that's okay because it doesn't really need to make sense. All you have to do is go to Stack Overflow or someplace, copy those out. That gets our mic going. So now we say, all right, you got a mic coming in. Let's read that audio, and then let's apply the pan echo to it. And now, what's going to happen, if you look closely, when I hit the play thing, you'll see that this audio clip will change and it'll say microphone, okay? And okay. And you should be able to hear my voice being echoed. Real time. Okay? So I just thought that was a nice thing to be able to show you guys too, because at some point you might want to kind of fool around with it and have fun with it. Hey. So guess what? That's all I had to show you. That's the end of the class. You've all got your hand up. Fire away.
Yeah, so because you can, in the C# script, sort of explicitly say which microphone you'd want to use, does that mean that you could actually, there's the possibility of like in one Unity session using multiple different microphones and stuff, which would have like with different things going into them?
Yes, if you had separate game objects and you had separate audio sources on each of those game objects, you could in fact have multiple inputs like that.
Oh, that's so cool. 'Cause I feel like that opens up like a lot of potential. You could have like multiple people in a room. If you had like microphones that were close to them, they could do different stuff, maybe lead to interactive things like that. That'd be really cool.
Yeah. Now, also bear in mind though that the thing that Jesse showed with his project is actually a more powerful way to probably accomplish some of that. Because you could actually, you know, MAXMSP or PD is set up to really do that kind of series processing. I think this is more if you just want to design a standalone thing that would work in a headset or something like this for an augmented reality application. You know, that's when this would be kind of really intriguing. You know, again, those are design decisions you'll have to make when you start thinking about what it is you want to try to accomplish. You know, but the tools are there, and you can do cool stuff with them. So, yeah, I think that's real fun. At some point, I really want to create a really bizarre world that you could just put on, you know, some kind of augmented reality glasses, and like the colors will all be enhanced and sound will be cool, and you know, stuff like that. So, yeah, one of these days. Alrighty. Yeah. So like I said, I will put these on the website. I will rename them to be week 11 because otherwise it's for my own sanity, because otherwise I can't find them when I'm looking through. Well, I don't have my screen share going, but my Unity hub has, I think, close to 50 or 60 projects in it right now. So I'm going to have to like clean out some of the stuff because some of them are pretty old. And yeah, building standalones. I was surprised at how easy it was when I was working on my large project and I built my first scene. It took it, probably 45 minutes to build it because it was pretty substantial, but there were like no errors, And then I transferred the code to the Windows machine and I built it, and there were like no errors. I was just shocked, not because I did a good job. It's because the Unity people did a good job. So, yeah. Not like MaxMSP. Yes, we all know the fun errors of MaxMSP. Very, very well. Cool. Hey, well, thanks for sticking with the class, everybody. And yeah, I'm looking forward to seeing what might happen next week. Vyoka, stay on. We can chat for a little bit. And yeah. Again, if you run into problems, drop me or Jesse a note, and we'll help you out. And see you next Wednesday. Again, next Wednesday, I'll send a note to remind you we will be live. We will meet in room 324. And like I said, I also want to show you how to set up and actually use the goggles and everything.